Spooky Halloween, everybody.
Hello.
This is one of our favorite times of year.
Absolutely.
Ding, 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 ding. And one of our favorite memories of Halloween is in 2019, before the world ended, we lit a pumpkin on fire with green fire.
Yeah, it was awesome.
It was so fun. We recently posted a reel of that on our Instagram, so you can go check it out. And you can also hear about how chemistry can turn fire green.
Yeah, since we published this episode 2 years ago, a lot more of you have found our podcast. And there's a chance that maybe you had not gone back and listened to some of our older episodes. But this is one we think you definitely don't want to miss.
Definitely.
Because it's Halloween again, we wanted to reshare this one and give you a chance to hear about how fire can be turned green.
And now on to the spooky show. Okay, you ready?
Yes.
I hate you so much. Hey, I'm Melissa.
I'm Jam.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life, Spooky Edition.
The podcast that spookily helps you understand the chemistry of your spooky everyday life.
Not your spooky everyday life, just your spooky Halloween life.
Your spooky Halloween life.
Happy Halloween, everyone.
Hey, guys.
I'm so excited that we have an episode airing on Halloween Day.
Pretty sweet. Hope you're chowing down on candy, or at least getting ready to.
I love Halloween. I hope you're dressed up as something cool, or you're going to get to.
Yeah.
Halloween is so fun.
Or maybe you're cool on the inside, and that's fine too. Maybe you don't need to dress up.
I like dressing up, even if I don't need to dress up.
Yeah. It's kind of fun sometimes.
One of my friends turned me in love with Halloween a few years ago when we went to her family's Halloween party, and
They go all out or something?
They go all out, and I just never realized that you can make really fun costumes and they don't have to be expensive.
Yeah.
It's just fun.
And ones that are kind of funny. Like, I love when people make a costume or have a costume that's like a little bit like a joke. Mm-hmm. And once you kind of figure out what's going on, you're like, oh, I get it.
Okay. Oh, what's your all-time favorite Halloween costume that you've ever worn?
One time I was in the Scooby-Doo gang with some people. I was the blonde one, and can't remember his name.
Shaggy.
Nope, that's not the blonde one.
Freddy.
Yes, I think it's just Fred.
Fred.
Yeah, I was Fred. And we happened to have the right number of people that we were like a group that hung out quite a bit in college that just all kind of already looked enough like different people in the Scooby-Doo gang. Like, I'm not like muscular or whatever like Fred is, but I had blonde hair, blue eyes. It was very, very, very easy for me to get the costume together.
Nice.
For that. Then also I dressed up as Flight of the Conchords with my friend Austin one time. And that was one of my favorite ones. Not everybody got it because they're not quite as well known of a group or whatever. But it was very fun to do that. I liked that it was a little more niche, even though it was kind of cool for everybody to recognize that we were the Scooby-Doo gang.
Did you have a Scooby-Doo? Did you have a dog?
Mm-hmm. Yeah, that one we had to do someone wearing a costume for that. Okay. The other ones we made the costumes for, found stuff thrifting or whatever.
Nice.
But
well, I only told you to do your all-time favorite, but I'll allow you to do two. I think my all-time favorite that I've ever been. One time I was Ron Swanson for Halloween.
Whoa!
And I killed it.
Dang, that's really cool.
And it was very cheap. I went to Goodwill and I bought just small men's clothing, and I made myself have a beer belly with a t-shirt. And my friend, shout out Katie Hubbard, friend of the podcast, she did my hair to look like a man's hairdo. It was so perfect.
Man, that's awesome. I don't think I've seen any photos of that.
Oh, we'll put a photo up of that one and your Scooby-Doo one.
Nice. Wait,
it'll be fun.
Can we do Flight of the Conchords and my Scooby-Doo one?
Yeah, sure.
We can put them into one photo if you want.
Yeah, we can do like a
so I don't take up too much.
Grid.
Yeah.
Well, Katie then was Leslie Knope, and she walked around with a binder all day and was very excited all day, and I was angry and tried to not laugh, which was very hard. So it was a fun costume. That is probably my all-time favorite.
Dang, that's fun.
And Katie is a sister of the friend who first got me involved in Halloween. So it's a family affair.
That's the family that was really into it?
Yes, the Hubbard family.
Nice. That's awesome.
Shout out Hubbard family. Love you guys. You know what'd be fun?
What?
What if we had anyone who's listening now share, I don't know exactly how to do this on Instagram, but share pictures of their Halloween, their all-time favorite Halloween costumes. And then is there a way we could take that and share it in our story? Share their post in our story?
I think so. I think they could mention us, or if they did it in their story and they mentioned us, we could definitely repost it.
Okay, let's do that. Okay, so anyone who's listening right now who wants to share your all-time favorite Halloween costume, since today's Halloween, and we will share it in our story. We'll share, if you tag us in your story, we'll reshare it in ours. And that'd be so fun to see everyone's fun Halloween costume.
Yeah, that'd be awesome. So Instagram's the easiest way to do that for sure.
Okay,
so
yeah, let's do it.
We can do it there. That'd be great. We'll find a way. Send it to us somehow.
If you don't have an Instagram, or if you're only on Twitter, we can definitely retweet it on Twitter.
Yeah, totally.
We're not great at Facebook, but you could email us and we'll put it on one of our things too.
Yes. That's a good idea. I like it.
I think that'll be so fun.
Yeah.
So that was a fun Halloween start, but let's get into our topic for today because I'm very excited about it.
Is our topic going to be Halloween-esque?
It's definitely Halloween-y. Halloween themed. I picked it because today's Halloween.
Okay, cool.
So today's topic is, I'm so excited, how to make green fire.
Green fire, like you can make the fire the color that you want it to be?
Yes, you were not as all excited as I thought you were going to be.
I'm so like you can make fire be a color.
Yes.
Okay, that's kind of nuts.
So you know in Harry Potter when they throw the flue powder and it turns green?
I do not know that.
Oh, you haven't seen Harry Potter?
I saw the movies a couple years ago.
I think they have that in there. In the book, they definitely have it.
It's been a while, and I'm not like a Harry Potter person or whatever, but I did see them.
Not at all going according to plan.
But I did see the movies, and I do like fire a lot.
Well, you clearly blocked this out because, honestly, they might CGI, but they have green fire in Harry Potter movies.
I believe you. It's just that it's been a while since I've seen them, but I only saw them once, but I like fire.
Okay. Well, so it's really cool.
Even if it wasn't in Harry Potter, I'd still be very interested because I do like fire and I like fire.
Well, today's episode is going to be about how you can make not only fire turn green, but how you can make that Halloween-y.
Whoa.
Are you ready?
Yeah, I'm very ready. Let's do this.
Okay. So turning fire colors is all about ions.
Okay.
Ions are, and we briefly touched on this sort of. It's kind of a different concept when it happens to a molecule versus an atom, but we talked about this briefly in the acid and base episode.
Okay.
So those we're talking about molecules, which are groups of atoms. We're talking about atoms by themselves, like the ones on the periodic table. So if an atom, something that you can point to on the periodic table, gains or loses an electron, it becomes positively or negatively charged.
Because normally it's just balanced.
Right. They're the same number of protons as electrons, so the positive and the negative charge even out.
Got it.
Yes.
So you're saying if it just gets out of balance, either in the positive direction or the negative direction, it becomes an ion?
Yes.
Got it. Okay.
So if you've heard of table salt, NaCl, actually table salt is made up of two ions. Na, sodium, has lost an electron, and chlorine, Cl, has gained an electron. One is positive, one is negative, and so they hang out very close to one another.
Got it. Also, earlier when I said I don't know what ions are, I should correct that I don't remember what they are. I know that I've learned it before, and Miss Pittard from high school chemistry, I'm very sorry that I didn't remember. It's been a lot of years. And Dr. Marshall from chemistry, whenever I was a freshman, I just didn't remember. It's been a while. So that should be the clarification I should give.
That's fair.
It's not that I was not taught it.
That's fair.
So, okay.
Yeah, I think they probably would think, I taught him that.
Yeah. I mean, if they're listening at all. But like, they'd be like, that's a very simple thing. I'm sure we went over that. Like, it's,
so,
yeah.
That is very pretty basic, simple stuff.
Okay.
Some of the very first things that you learn in the first semester of chemistry, even in chemistry for non-majors.
And I know I've heard the word a ton. It's just that it didn't stick with me at all.
Right. We very briefly touched on this in a Q&R episode.
Okay.
We had a question from a listener, Ryan, about energy, and we talked about how energy is absorbed. And when the energy is absorbed, electrons will move to higher, the best way I can describe it is as shelves. So if an atom absorbs energy, its electrons become excited and they jump, just like when little kids get excited, they jump, you know? They'll get excited and jump up to a higher shelf.
Okay.
Then if the heat is no longer being put in, or if the energy is no longer being put into the molecule, eventually those electrons aren't excited anymore. They don't have energy holding them up there anymore, and they'll come back down, just like when a little kid crashes for a nap.
Sugar rush kind of deal.
Sugar rush. Electrons do a similar thing.
Okay.
They accept their energy, they go to the higher shelf, and then they let their energy back off as they fall back down to the normal state, the non-excited state.
Yeah.
So sometimes when that energy is let off, it's let off in certain increments that happen to be visible to the human eye.
Oh.
And that goes back to our visible region that we talked about in the microwave episode and in the sunscreen episode.
Yes.
So sometimes when an atom or even a molecule absorbs energy and lets it off, that shows to you as color.
Whoa.
And there are a couple iterations of this. We're going to talk about it in different contexts on down the line. But for today, that matters because if you put copper ions and dissolve them in a flammable solution and then light that solution on fire, the copper ions are absorbing energy and then letting it off as green light.
Whoa. That's crazy. So you just have to put it in something flammable. Those ions.
Yes. If you just
like
try to
fluid or something.
Yes. If you just try to light copper on fire.
Yeah.
That wouldn't be an effective method. The most effective method that's known now, and this is very dangerous. I want to give a disclaimer.
Oh yeah. That's a good
idea. Do not do what I'm about to say unless you are a chemist and you're in a safety setting and you have personal protection equipment. You can dissolve metal salts like copper in methanol and then light methanol on fire. And if you light that methanol on fire, because it's very flammable, it will be green.
That is insane.
Yes.
That's so crazy.
Isn't that so cool?
Just because it's a different thing that was being burned. Like there's something else, another part of it, and it changes the color. Because I always have this idea in my mind. Like I think sometimes I've seen different colors of fire because I'm burning a plastic thing that's a different color. And it's very brief. It's like when you're a kid and you throw the wrapper to your Pop-Tart or something like that.
Right.
In the fire. Because it's a color, you kind of see some colors happening. It's not really the same thing though.
Right.
But I am, for the most part, have an idea in my head of what color fire is. It's that like yellowy orangeness.
Right.
And that's it. Sounds like a little bit of blue at the very base or whatever. But
that's
the idea
from it being extremely hot.
The idea of being able to change it on purpose is cool. That's cool.
It is cool.
I'm here for that. I wish I knew how to do it and was safe enough to, but of course I will not do that unless I'm under the supervision of a chemist.
Absolutely right. And I have a video that we're going to post online of a demonstration where someone sprays methanol with copper salt dissolved in it onto a Bunsen burner, and you can see the cool spurt of green flame.
Will you tell me what I have to do to convince you to allow me to be part of some experiment that creates green fire?
Well, I'll tell you what. If you go to the ACS website, that's the American Chemical Society, they have a fun Halloween chemistry page, and we can link to it in our show notes.
Okay.
And on that, you can click on pumpkins. And then if you scroll down, there is an experiment called Rainbow Fire Jack-o'-lantern.
Okay.
We'll link to that in the show notes.
Okay.
That takes you to a page that shows you a safer method of having a pumpkin on fire that's colorful.
And can we do that?
I think that we will be able to do that today and post a video of it.
Oh my gosh, dude, that is way cool. I'm ready. That was actually a lot easier. I thought I was gonna have to like do some fancy footwork or like have to buy you something or something like that to convince you to like let me do that.
I should. Well,
Too late now. You already said.
I'm so excited about science that you don't usually have to convince me to let you do an experiment.
That's a good point. That's a good point. I was right not to tell you that I was gonna like potentially buy you something or whatever to convince you to do that.
Well, so for this, you need to be very safe. You need to be careful. And because it's a fire experiment, we don't want any kids to do this without their parents around. It's probably safest if it's not near anything flammable, maybe on some concrete, far away from grass, far away from any kind of solvent or liquid that goes in your car.
Yeah.
A pile of sand, even better. Mm-hmm. And it tells you there's some chemicals available to buy that have some copper salts in it that you can use to burn, and then you can use hand sanitizer as the liquid you dissolve it in, because hand sanitizer has a high water content, so it's likely to extinguish quickly, so it won't be as dangerous as pure methanol.
Got it. So it is flammable, but not like quite as flammable.
Right. And you can have your cool rainbow fire pumpkin.
Dude, that's so cool.
I'm very excited.
I'm surprised at how simple it is too.
Mm-hmm.
Meaning like, not that I just have like copper salts lying around or whatever in my own house that I know of, but just the idea that like,
probably not.
You change something small about what you're burning, about like what you add to the fuel or whatever. And then the fire's like, all right, I'll be this color now.
It varies about what you're burning.
Mm-hmm.
Fire is very much about what you're burning. And then the more complex part, we've already learned a lot about it, the electromagnetic spectrum, and that sometimes energy is emitted in terms of visible light. And we've learned about electrons and that they absorb energy. And so you had all the tools in your toolbox, and most people who've been listening for the last few episodes have the tools in their toolbox to be able to understand this pretty easily.
Yeah.
So it's very cool.
Okay, so like we're talking about earlier, the fire's kind of like a kid on a sugar rush.
Mm-hmm.
The ions are kind of like the sugar in a way, because the energy level of the electrons kind of go up a notch in energy because of the ions, correct?
That's okay. That's a good thing to point out. So actually, say it's really the distance they go up. So normally when we heat up fire and we let it down, the electrons jump up and jump down a amount if they're burning just normal fuel. But when we add those ions in there, they're able to absorb a new amount, maybe a plus 2 more joules or whatever of energy. And that is the same amount that they'll then let off. And that is the thing that changes color. So it's almost like we adjust the distance between the two energy levels or the amount of energy it takes in. And the change in the distance is what makes the change in the color.
So kid is eating more candy this time. More sugar.
Yes.
Not like zero sugar to a lot. It's like some sugar to more. The distance that the energy level is going up and then back down, that's a higher amount of distance.
Yes. And for the electrons.
For the electrons. And so it'd be like if your kid had a sugar rush and when the kid crashes, coming back down off of that high, your kid turns green.
Yes, as they're burning off the energy. So it's almost like their normal energy level is the ground state of electrons. And then as they get excited, the electrons get excited. The kid is equivalent to the kid eating candy. And then they hit a peak and come back down. And the burning off of the energy, the child running around in circles because they're so hyped up, the burning of that energy, the letting the energy off, is the moment that the light is let out.
Yes, and your kid turns into Shrek.
Yes.
Got it. Okay, cool.
So if somehow they were suddenly able to absorb slightly more energy from candy than normal, and then they turned green when they were burning all that energy off, that is basically what's happening with fire.
Got it. That's pretty awesome.
It is. I think it is amazing that we can change fire colors. And there's a lot of applications that are going to come up again later, but it is so cool.
Yeah, I'm a little like, it seems like something was just unlocked. You know what I mean? It's like, okay, fire is always this color, but in my mind, that's like a rule or something. I don't know, whatever. But it's like, you're just like, no, actually, it can be different colors if you want it to be. It's like, what?
You got it.
I like it.
I liked your kid excitement. Your kid excitement example. That was good. So that's it. That is this week's episode on how to turn fire green. How to have a happy Harry Potter spooky green flame Halloween. Well, Jam, what are your big exciting Halloween plans?
Well, I will be celebrating Halloween by going to New Zealand. My wife and I are leaving the day that you guys are hearing this. We'll be leaving for New Zealand. Unrelated to Halloween, sort of. Like, we don't normally
what time of day?
I don't remember, actually. I probably should know that, but it's, yeah. I would guess it's pretty early. I don't know. So we'll be headed to New Zealand for a trip. We haven't gone on a trip together in a while. So we're overdue. And yeah, we're looking forward to it. So we'll be Halloweening Down Under.
Is it called Down Under if it's New Zealand instead of Australia?
Yes, because they're both down under.
Okay, cool.
I actually don't know. I don't know if they consider themselves to be in that category, but the things that make it true that Australia is down under are also true of New Zealand. That's how I would say it.
Well, I'm glad that you're going to New Zealand. I think it's going to be beautiful.
I hope so too.
I wish you could take me with you.
Yeah, it's going to be sweet.
So that's your happy thing for this week?
Yes, that's making me happy, and hopefully we are on our way and all is going well when y'all hear this. But yes, I'm excited about it.
Very exciting. Yay.
What about you? What are your Halloween plans?
Well, we're having to record this in advance, so I don't know what my Halloween plans are just yet.
Oh.
But
TBD.
TBD Halloween plans, but I'll say something that makes me happy. This is seeing a silver lining. But because Jim's going to be out of town for a few weeks, I'll have big chunks of time to work on my final project for one of my classes, which October 31st, this bad boy is due 1 month from today.
Oh, wow. Awesome. That's a kind of cool, like, unexpected benefit.
Unexpected benefit. So I'm looking forward to getting a lot of things done while you're away and we are missing some recording sessions. And hopefully by next week's episode, I'll have knocked out quite a bit for my final project.
Dang, that's awesome.
Yeah. Also
really good that you won't be bored while we're gone and we're not recording. Something you have plenty to do.
Yeah, I'm going to be bored. I would not. If it wasn't for school, I'd be bored and sad and have to fill my time up. But I guess I'll be able to survive since I have so much homework. So my sources for this week's episode are actually just the knowledge that I already had. But I did use the ACS website for some Halloween experiments, and thoughtco.com is the website that we're going to link to with the safer, but please still be careful, rainbow fire pumpkin experiment so that you can have a fun and spooky Halloween. Thank you guys so much for joining us this week and for learning about green fire. And thanks, Jam, for being such a good listener today.
Dude, anytime. Especially, I mean, it's fire. I mean, who's not like just on the edge of their seat when it comes to this kind of stuff? So, Melissa and I have a lot of ideas for topics of chemistry in everyday life, but we want to hear from you. So if you have questions or ideas, you can reach out to us on Gmail, Twitter, Instagram, Facebook at Chem for Your Life. That's Chem, F-O-R, Your Life, to share your thoughts and ideas. And if you enjoy this podcast, you can subscribe on your favorite podcast app. And if you really like it, you can write a review on Apple Podcasts. That helps us to be able to share chemistry with even more people.
This episode of Chemistry for Your Life was created by Melissa Collini and Jam Robinson. Jam Robinson is our producer, and we'd like to give a special thanks to A. Collini, who reviewed this episode.